Hey guys, we did this lesson 2.4, perpendicular and parallel lines. All right, and then we used that information to answer these questions if they're parallel, perpendicular, or neither. Right? And then we didn't finish this last one, this question number 6, so we'll have to do that. And you'll also need to do these 3 questions, right? We want to answer these 3 questions. So you may need an extra piece of paper to answer these questions. You also may need graph paper, okay? Let's see if I have graph paper. I don't think I do, so I'll have to import some. All right, so I'm going to start with these questions, and then I'll go back to question number 6 because it has a lot of parts. Question number 1, are the lines whose equations are this and this parallel, perpendicular, or neither? Okay, so the first thing I'm going to do is type this into Desmos. This is a way using a graphing calculator to check. So it's 2x minus 5 and negative 2x minus 5. So I'm going to a website, Desmos. There it is, desmos.com, and this is an online graphing calculator. And you don't need to sign up. You can just click graphing calculator and get started. So our equation was y is equal to 2x minus 5. I think that's what it was, 2x minus 5. 2x minus 5. Okay, and so we see here, this is the line, 2x minus 5. Now looking back here, did I write that out? Yeah, 2x minus 5. So the line 2x minus 5 is here. And we should know some things about it from last year. It looks like the intercept is 5, right? That's that number, mx plus b, the number on the end. And it has a slope of 2. So notice it's going up 2 over 2, up 2 over 2, okay? Now, what else? I'm supposed to compare it to this one, negative 2x minus 5. So I'm going to click on 2 and make another one. Y is equal to negative 2x minus 5. Interesting. So I see here that these are not meeting at a 90. So I'm just going to take a picture of this. You might want to jot this down. And I'm going to crop it. I just want these 2 graphs to be visible. And now I'm going to go back to my worksheet. So you might want to jot this, like I said, on another piece of paper. I'm going to stick it up above here, right here. So I noticed that 2x so question number 1, I'm going to say neither. Okay, so now how would we know that though? Because you might not think to use Desmos, or what if Desmos isn't available on a test? So we know this, y is equal to mx plus b. We knew that from last year, and m is the slope, right? So if we look at the first equation, y is equal to 2x minus 5, we recognize that the slope is 2 of our first line. So I'm just going to put a 1 there. The slope of our first line is 2, or we could think of it as 2 over 1. Now our second line, negative 2x minus 5, has a slope of negative 2. So the slope of our second line is negative 2, or negative 2 over 1. Now, there's something that first looks good, right? We had a rule today that was 2 parts. 1, it has to be opposites. And these are opposites, right? Positive 2 and negative 2 are opposites, but they're not reciprocals. So that's why they are not perpendicular. Okay, so that's question number 1. Question number 2, it says, would these 2 lines be considered parallel, perpendicular, or neither? Okay, so a couple ways we could do this. We learned 2 specific techniques. So we can look here. it looks like you went down 1, 2, 3, 4, 5 over 1, 2, 3, 4, 5, 6. And they've confirmed that this is on the hash line. So the slope of MN segment is down 5 over 6. So for this to be perpendicular, it's got to be plus 6 over 5. The opposite of negative is positive, and flipping this upside down, you'd get 6/5. So let's take a look what the slope is. The slope here, AB, is up 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Oh, no. So the slope of AB is positive 7 over 5. So we're going to say no. They are neither. Because their slopes are not opposite reciprocals. They're opposites, but they're not reciprocals. Okay, and they were definitely not parallel. They don't have the same slope. Okay, the last one says, PQ has an endpoint at here and here. RS has an endpoint at here and here. Are these two line segments parallel, perpendicular, or neither? So question number 3 is exactly like number 2. They're giving us 2 points on a line, 2 points on a line. They just didn't graph it for us. So we can take this to Desmos if you want. Negative 4, 6, and 3, 4. Negative 4, 6, and 3, 4. So I can X those out and put in the coordinates. Negative 4, 6. What am I supposed to label that? Negative 4, 6, O would be P, and 3, 4 is Q. P, 3, 4. We're going to label Q. It didn't like Q. Okay. So where is this? Okay, here it is. So it looks like if I zoom till each box is 1. Yeah, so I've adjusted it until each box at 1. It looks like I'm going down 2 over 1, 2, 3, 4, 5, 6, 7. Down 2 over 7. So the slope of BQ is down 2 over 7. Well, it's like, could I have gotten that without graphing? You might have noticed that there's 2 between the 6 and a 4, and there is a 7 on a numbered line between the negative 4 and 3. So you may have seen this formula before. The slope is the change in the y over the change in the x. So you could do this algebraically as well. We could have done the y values, 6 minus 4, and the x values, 3 minus a negative 4. So that's where we're getting, this is the same thing. The negative actually goes outside the fraction. It's not really on the top or the bottom. All right, now let's see the other one. So we could again graph it, or we could just do the math. So let's do the math. The slope of RS would be subtract the 2, 4 minus negative 2, which would be 4 plus 2, or 6. And the denominator would be negative 8 minus 13. So that'd be a negative 21. These are not opposite reciprocals, so no. And they're not the same, neither. They are not the same and are not opposite reciprocals. Okay, well done, guys. Now, I'm just double checking my work here. All right, looks good. So now we're just going to work on these. And if you didn't get 5 checked, we can take a quick look at it. So 5, it looks like we went, there's some dots that line up there, but up 3 over 1, 2, 3, 4, 5, 6, 7, 8, 9. The slope of AB is up 3 over 9. That would be the same as 1/3. This line, it makes the same slope triangle. Notice it makes the same slope triangle, is oriented in a different way. Right? You see these? So this slope is fall 1 over 3, fall 3 over 1. So the slope of NM is fall 3 over 1. Those are opposite reciprocals. Yes, this is perpendicular because their slopes are opposite reciprocals. Okay, so question number 6. It says AB has endpoints at -3, 6 and 7, 2. So let's go ahead and graph that. So there's 7, 2, which is point B, and -3, 6, which is point A. Okay, and it says MN has one endpoint, 2, 1. M. We don't know if it's M or N, but let's just assume it's M. What could be the coordinate of the second MN so that AB and MN are parallel? So looking at AB, right, we have a straight line here. We want to see what's the slope. So the slope of AB is, it looks like we went down from 6 down to 2 in the y, right? So that's down 4 over 3 and another 7, so that's 10. Down 4 over 10. And this is up here at 2. All right, so the slope is down 4 over 10, which would be the same as 2/5. So to be perpendicular, the slope perpendicular to that would be positive 5/2. What could be a coordinate? So if you go from M and you want to go up 5, so I'm already here over 2, up 1, so I want to go up another 5, so I'd be up at 6, right? Up 6, up. So from this dot, I want to go up 5 over 2 more, 1, 2. Well, I'm already over 2, so that'd be a total of being over 4. So if I added this dot, 4, 6, that would be perpendicular. That would make a 90-degree angle because it would have the slope triangle positive 5, 2. And there could be multiple, right? This line goes on forever. So I could put a dot anywhere on here. I just decided to pick the first dot I'd come to if I went up 5 over 2. But do you notice I actually messed something up? I got perpendicular. So my coordinate for perpendicular is 4, 6. I answered part B. What if it were parallel? Okay, so if it was parallel, it would be parallel would have the same slope. So parallel has the same slope. All right, so that would mean just like here when I went down 4 over 10 or down 2 over 5, I want to go from, I'm over here at 2, 1, I want to go down 2 over 5. 1, 2, 3, 4, 5. So where do I end up? Well, I end up at 1, 2, 3, 4, 5, 6, 7, and it looks like I'm down 1. So I end up here at 7 down 1. And there's multiple answers to this, but this would be one correct answer because I've made a line that's parallel. And in fact, I could pick a true answer would be any point along here. I just picked the first point I'd come to if I left the point M and I went down 2 over 5. Now it says, what could be the coordinate of the second endpoint so that A and MN would be neither? Again, lots of possible answers. It looks like if one easy one though is if we went through 0 and M, it's going to be neither. It's not the same slope as this original line. And again, I don't want to lose track of, this is our original line and this is our original point. If the other end of MN was the origin, it would definitely be neither. So I'm going to use that. The next one says, what could be the coordinate of the second point so that AB and MN would be intersecting? Oh, neither parallel, no perpendicular. I did it again. I answered D when I thought I answered C. So let's look at C. What could be the coordinate of the second endpoint MN so that AB and MN would be neither intersecting? So notice here when I pick the origin, it ends up intersecting with my original line. And so that's what I answered D. So how could I pick a point where I'm not parallel, but I'm not intersecting? And I feel like any point I pick, it doesn't matter where, it's eventually going to intersect. So I'm going to have to say, what could be the coordinate? I'm going to have to say there isn't one. So this goes to what many people said in class. Parallel means they're never going to meet. And that is true as long as they're on the same plane. So there isn't one. If they are parallel, they won't intersect. Okay, last one, E. What could be the coordinate of the second endpoint of MN so that the line containing AB, my green line, and the line containing MN, and I still don't know where that is, it's just at this point, just right here, and I can draw it anywhere. I could draw it here to make it perpendicular. I could draw it here to make it parallel. I could draw it here to make it neither if I use the origin as my other point. So they're asking what could be the coordinate of the second MN so that the line containing AB and the line containing MN would be perpendicular, but the segments would not be so that the line would be perpendicular, but the second segments wouldn't be. Okay, so notice I picked this coordinate and these segments are perpendicular. And if we extended these lines infinity, they're perpendicular. I see what they're saying. So they want me to pick a coordinate but that's perpendicular but ends up being maybe over here. You see what I'm saying? Okay, maybe you don't, maybe you do, but we'll go with it, right? So I can build a line backwards and it still has to have this slope. So I have to go here. This was 2 and 5. So I have to do that again. 2 and 1, 2, 3, 4, 5. Bam. This coordinate would build a segment, MN, that if it was just the segment, it's not perpendicular to the green line. But if we extended them, it would be. Okay. And again, I could have continued this line, making this segment longer, and any point along this line would have fit the bill. But this is just the first hash mark I would come to. And that coordinate looks like the coordinate 0, -4. 0, -4. I went back 2, down 5 from the coordinate to 1. That's it, guys. Have a great weekend.